All right, here is an example of another redox in acid equation. So I'm doing number 73, C, because it has a couple more little things that you need to remember that A doesn't have. So I want to walk through C, so in case you need some help, you can do this. All right, so first thing we know we need to assign the charges and we need to find our half reactions. So I can start with oxygen. I know that that is -2. This is going to have an oxidation state of plus or -6. So I need to have +6 on the other side. So I know that arsenic here has to be +3 to get that to a +6. Going on to my nitrate ion, I know that oxygen is -2. This is going to be -6. My nitrate is an ion with an overall charge of -1. So this has to be +5. Then over here, I have, again, I know that hydrogen is going to be +1, so that's +3. I have oxygen, that's going to be -2, -8. And again, my overall compound is going to be 0, so this has to be +5. So that +3 +5, subtract 8 is 0. Here I have nitrogen monoxide, and so this is going to be -2, then this nitrogen has to be +2. All right, so go through and find my half reactions, and I can see that my arsenic is changing from +3, make sure you pay attention to the initial charge, +3 to +5. And so that is going to be a loss of electrons, so this is going to be my oxidation half. And then I take a look up here at my nitrogen, and my nitrogen is changing from +5 to +2. And so that is gaining electrons, so this is going to be my reduction half. Okay, hopefully that makes sense to you. Now we're going to start with our oxidation half reaction. So I'm going to start with my arsenic oxide. And this is some sort of acid over here. Okay, so as I take a look, the first thing I need to do is I need to balance my elements except for oxygen and hydrogen. So I have 2 arsenic here. So I'm going to put a big 2 out in front here. And so now I have 2 arsenic. I do want to remember to carry down the charges that change. So we had this as +3, and that is going to be +6. We had this at +5. And now that I have added my coefficient of 2 out in front, this is going to be a +10. Okay, so now I need to go ahead and balance the elements. I did that. I'm going to balance my oxygen. Here I have 3 on the left and I have 4 on the right. And I'm going to balance this with water. So I'm going to, 2 times 4, I have 8 oxygen plus 3. So I need 5 waters on the left-hand side. Excuse me for that. And now let's count up our hydrogens. On the left, I have 10 hydrogen. On the right, I have 6. So I need 4 more hydrogen ions on the right-hand side. Now last thing I'm going to do is analyze my electrons. So on the left, I have +6, and on the right, I have +10. So I need to add 4 more electrons to the right-hand side to balance this one out. Okay. Now we are ready to do the other half, which is going to be our reduction half. And so we're going to take our nitrate ion, resulting into nitrogen monoxide. And again, let's pull down the one that changed, and that is our nitrogen. So we had this at +5, and we had this oxygen at +2. Okay, so the first thing that we need to do is we need to balance our elements, except for oxygen and hydrogen. So 1 nitrogen, 1 nitrogen, that looks good. Now we need to balance our oxygen. We have 3 oxygen here and we have 1 here. So I'm going to add 2 more waters on this side. So now my oxygen are balanced. And then I have 4 hydrogen here. So I'm going to add 4 hydrogen on this side of the equation. And the last thing that we do is we need to balance out our electrons. And so I have 5 and 2. So I need to add 3 more electrons to this side, and that will result into a balanced equation. Okay, now I want to try to add these up. And as I do that, I can see I have 4 electrons here, and I have 3 electrons here, so my common factor is going to be 12. So I need to multiply this whole thing by 3, and I need to multiply this whole thing by 4. So I think I am going to show you how it might be helpful for some of you to rewrite equations when we are doing a lot of multiplying through. So I'm just going to take and multiply this through. So I will have 15 water. I will have 3 of my arsenic oxide. I will have 6 of my acid. Use my pen here. I would have 12 hydrogen. You might be hearing the voice in the background. I am watching that. Plus my 12 electrons. Okay, so then if I do my other half reaction, I'm multiplying by 4. So 4 times 3, I have 12 electrons here. 4 times 4, I have 16 hydrogen. I have 4 nitrate ions. I have 4 nitrogen monoxides. And 4 times 2, I have 8 waters. Now this might be a little bit cleaner so that we can go ahead and add these 2 reactions and cancel out the quantities that we need to cancel out. So you can see that I have 12 electrons on the right, canceling with 12 electrons on the left. Now I have 15 waters on the left, and let's see, I have 8 over here on the right. So I'm going to subtract that from my 15, and that's going to give me 7 waters. And at room temperature, this is going to be a liquid. Okay, the next one I have is I do not have this anywhere else in my equation, so I'm just going to copy that down. And they gave us to this as a solid. So I am done with this quantity. Then I can go on to my 16 hydrogen and 12 hydrogen. So I'm going to subtract that here. 16 subtract 12 is going to give me my 4 hydrogen ions. And then I'm going to add my 4 nitrate ions. And I'm done with my left-hand side. So my reactants are complete. Now I need to do my products. And I have 6 acids. And that is an aqueous substance, for acids are all aqueous. And we have 4 nitrogen monoxides, which is in the gaseous phase. Okay, that's it. That is our balanced equation. One more thing that you can check yourself on. If you take a look at this, I think you would agree that my charges need to equal on both sides. So right here I have 4 positives, here I have 4 negatives, so that's going to equal 0. And over here I don't have anything with a charge, so that is also 0. That's just another quick way that you can check yourself that you have done your equation correctly. So we are done for the night. Good luck on your redox in acid equations. I will see you in class. Have a wonderful night.